of radius 1 meter is given to you. Okay, and this is sliding with rolling on an inclined plane. So let's say if this is the inclined plane, right? If this is the inclined plane, right? Right? Then you can see here is the barrel. Let's say the barrel is here. The barrel is just as a cylinder. Okay, so there is a slope. Okay, you can see this slope over here, and on this slope a cylindrical barrel is rolling, right? So this is the barrel whose direction is in two direction. One is in this way, and along with rolling, this barrel is also it's not sliding, but it's rolling against its axis also, like this way. So it's coming with a roll like this, right? And when it reaches at this point, bottom point, we need to find the velocity of this barrel, right? So the data as given to you into this question is that the cylindrical barrel of radius 1 meter. So the radius, this radius r, radius of barrel is given to you as how much? 1 meter, right? So 1 meter is the radius of this cross section of barrel, right? So this is the cross section, right? And this is having its two direction. It's just coming down with a roll, right? Now what we need to find, let us write down the data as given to you into the question. Okay, so the radius of the barrel is 1 meter, right? And it's given that without slipping it's rolling and on an incline through a distance of 5 meter if the angle of inclination of the plane with the horizontal is sine inverse 4 by 5. That means this data, this theta is given to you as sine inverse 4 by 5. So sine inverse of 4 by 5, what does it mean? That means the value of sine theta is 4 by 5, right? That means this 4 is your perpendicular. So this length is 4, in trigonometry, ratio of perpendicular to hypotenuse is your sine theta, right? So this is 4 meter, which is your perpendicular, right? And the hypotenuse is 5. So this length is 5 meter, right? This is 5 meter, right? And it's also mentioned into the question also that this cylinder, it's coming like this. You can see it's coming like this. It's just rolling and coming like this, right? So we need to find the speed of the cylinder when it reaches at this point, right? Now a cylindrical barrel of radius 1 meter rolls without slipping on an incline through a distance of 5 meters. So it slides through a distance of 5 meters. That means you can see this is matching with the data is given into the numerical. The hypotenuse is 5, right? So this is 5 meter. Now if the angular of inclination is mentioned, calculate the linear speed. So students, first of all, you can see when the cylinder is placed over here at a height of 4 meter, right? At a height of 4 meter, let's say 4 meter, okay? Then what is the potential energy? The loss of potential energy from this point will be the gain in the kinetic energy, isn't it? So the loss of potential energy is equal to gain in the kinetic energy, right? So I'm mentioning here it's loss and here it's gain, right? Now the kinetic energy over here we are of two types, right? What's that? One is translational, one is translational, which we generally know half mva square, and another is what? Tell me. Rotational. Yes. Why rotational kinetic energy is coming over here? Because this cylinder is coming with a roll like this into this inclined plane, right? So that's why two component of kinetic energy will be there. One is translational and one is rotational, and the value of potential energy is how much? It's mgh, right? So the potential energy will be equal to mgh, right? And this potential energy is retained or attained due to the position of this cylindrical barrel at a height of 4 meter, right? Now what we can do, kinetic energy of translational, it's what is the value of this? The translational kinetic energy is half mva square, right? And what is the value of rotational kinetic energy? Rotational kinetic energy is half, tell me, half I omega square, right? Half I omega square. Now let us do one thing. Just put up these values and equate it, right? So we can do it. So the potential energy will be equal to mgh, right? And this is equal to half mva square, that means the translational one, plus half I omega square, right? Now what we can do, we can just you can just put up the value of I. What is the value of I for a cylinder? For a cylinder, I is moment of inertia of cylinder, which is equal to half into m into r square, half mr square, right? So just put up all these values and equate, right? You'll get the value of v, right? Now here you can see, when you put up the value, you can see mgh will be into the LHS, and into the RHS we have half mva square, half mva square, right? And we have the third term, half I omega square, right? So just put up the value of that half I omega square, right? What is the value of half I omega square? Since I is calculated as half mr square, you can see half mr square, so we can write half into plus the value of I as half mr square, into omega square, right? Now you can see here m is common in all the terms, which can be cancelled, right? So we are left with gh is equal to you can just take V square by 2 plus, you can write R omega as V, right? Here you can see R omega as V. So we can write V square by 4 over here. You can see R square omega square. V equal to R omega, right? So G is, let us put up the value of G as 10, right? And H, you can see the height through which it falls. That is, H is 4, the potential energy. Sin inverse 4 by 5 was given to you. So we put the value of H as 4. And V square by 2 plus V square by 4 will give you 3 by 4 V square, isn't it? 3 by 4 V square, right? Now, in the second step, you can see 10 for 40 into 4, that is 40 into 4 by 3 will be the value of V square. And when you take the square root into both the sides, right, you can see 1 4 will be coming out and root over 10 by 3 will be under root, and here into the RHS V will be coming out. So you can see V as the velocity of the barrel is calculated as 4 times root over 10 by 3, and this will be in meter per second, right? And this is your answer, students. If you find it useful, you can just like and subscribe. Thank you so much, students. Thanks so much for watching. Take care and bye bye. Happy learning. Let us be connected. Okay. Thank you.